Hi everyone, welcome to our class. This is the second part of our discussions about set. Today I am going to discuss subset and superset, universal set and power set, and operations on sets. We start our discussion on subset and superset. We have here the definition. If each element of set A is an element of set B, then set A is called a subset of B. We use this symbol and read this one as A is a subset of B. Using the same definition that the elements of set A is an element of set B, we call B as a superset of A. Denoted by the symbol B is a superset of A. Again, in these two statements, A is a subset of B and B is a superset of A. It tells us that all elements in A are elements also in set B. Let us have these examples. A has elements 2, 4, and 8. B has elements, all the counting numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And C has elements 8, 4, 2, and 2. Tell if the statement is true or false. So the first statement is A is a subset of B. So to tell if the statement is true or false, all you need to do is simply answer the question. Are all elements in A contained in B? So we look at the elements in A, 2, 4, and 8. Are all of these elements found in B? So we have here 2, 4, and 8 are present in B. Therefore, the statement A is a subset of B is true. The second statement, C is a subset of A. So the same question will be asked, are all elements in set A contained, or are all elements in set C contained in A? So we look at the elements in set C, 8, 4, 2, and 2. Take note, in a set, an element which is written more than once is considered as the same element. So we have here the elements are 8, 4, and 2. We look at the elements in set A, 2, 4, and 8. So they are the same elements, and so therefore the statement C is a subset of A is true. Let us have this one. B is the subset of C. So the question is, are all elements in B contained in C? So we look at the elements in B, 1, 2, 3, 4, up to 10. We compare that one to the elements in set C. Obviously, there are lots of elements in B which are not found in C. So the statement B is a subset of C, therefore is false. Let us have B is a superset of A. Again, in the statement B is a superset of A, it's just like asking, are all elements in A contained in B? So we go back to the elements in A, 2, 4, 8, and obviously they are all found in B, and so the statement B is a superset of A is true. C is a superset of A. So in C is a superset of A, again the question will be, are all elements in A contained in C? So we look at A, the elements are 2, 4, 8, and C has elements 8, 4, and 2. Again, all the elements in A are found in C, and so therefore we say the statement is true. So you take note in writing the elements in the set. Elements common to sets are considered the same element regardless of their arrangement. Elements written more than once is considered the same element. Okay, there are facts about subsets. In the statement A is a subset of B if all elements in A are found in B and there is at least one element in B which is not in A, then A is a proper subset of B. And we use this symbol. A is a proper subset of B. Let's have these examples. A set containing the elements 3, 6, and 9 is a proper subset of 11, 9, 6, and 3. Let us try to check from the definition. So the given condition is that all these three elements should be found in the second set, regardless of their arrangement. So we have 3, 6, and 9. And there is this one element in the second set which is not an element in the first set. Therefore, we say the first set is a proper subset of the second set. We have a set in here containing the elements D, A, R, and E is a proper subset of the set whose elements are B, R, E, A, D, and S. So each of these elements, D, A, R, and E, are also found in the second set, D, A, R, and E. And there are two elements in here, B and S, in the second set, which are not found in the first set. Therefore, the statement is true. That is, the first set is a proper subset of the second set. In the statement, A is a subset of B. If sets A and B have the same elements, meaning all the elements in A are elements in B and all elements in B are also elements in A, then we call sets A and B as equal sets. We use the symbol A is equal to B. Example, we have here a set containing the elements 3, 6, and 9 is equal to a set whose elements are 9, 6, and 3. Okay, so each of the elements in the first set are also found in the second set, 3, 6, 9. And all elements in the second set are also found in the first set. We have here a set containing the elements R, I, V, E, and R. It is equal to the set containing the elements R, E, V, E, R, I, E, or the letters in the word reverie. So take note that the elements in the second set, E is written 3 times. R is written twice. In the first set, we have here R is also written twice. So these two elements are considered as one element. 3 is in here are considered one element. So let us try to check. R is also found in the second set. I in the first set is also found in the second set. V is also found in the second set. And E in the first set is also found in the second set. Similarly, from the second set, R is also found in the first set. E is also found in the first set. V in the second set is also found in the first set. I in the second set is also found in the first set. Therefore, we say the two sets are equal sets. That is why we say in any set, every set is a subset of itself. So we have here A is a subset of A because they are actually equal sets. Then the third is an empty set is always a subset of another set. Take note of the symbol for a null set. This is a set is always a subset of any other set. Okay, we have an empty set is a subset of another set. Now, if there is at least one element in A which is not in B, then set A is not a subset of B. We use this symbol to denote not a subset, meaning there is at least one element in A which is not found in B. Okay, example, we have here a set containing the elements 0, 5, and 10 is not a subset of the set containing the elements 5, 10, 15, and 20 because this element is not found in the second set. Or we have here a set containing this element, the symbol 5, is not a subset of the set containing the elements 0 and 2 because this element is not found in the second set. A universal set is a set which contains all the elements of the related sets without repetition of common elements. Let us have this example. Write the universal set of the following sets. A has elements 1, 2, 3, 4. B has elements 2, 3, 5. C has elements A, B, and C. And D has elements B, A, and G. The universal set is simply a collection of all the elements found in the given set. So we can represent that one with a U. We start from A. The elements 1, 2, 3, 4 should be found in the universal set. B has elements 2, 3, 5, and since 2 and 3 are already written the universal set, we just add in here 5. C has elements A, B, and C, so we add in here the elements A, B, and C. And we have D has elements B, A, and G. Since B and A are already written the universal set, we just add the element G. So this is now the universal set representing all the sets under consideration. So maybe the question this time is, how many subsets will there be for a given particular set? Or if we have in here our U representing all these elements, how many subsets do we have in this set? Okay, so to determine the number of subsets in the given set, we use the formula. If the cardinality of a set A is equal to n, then there will be 2 raised to n subsets for set A. Example, we have in here set A whose cardinality is equal to 5, meaning there are 5 elements in set A. Therefore, there will be 2 raised to 5 or 32 subsets that we can write from set A. If the cardinality of set B is equal to 4, then there will be 2 raised to 4 or 16 subsets for set B. A power set. A power set is the set of all subsets of a universal set. So it is important that we should know how many subsets will there be in a universal set. And those subsets will become the element of the power set. So the power set of a universal set, let us say we have a universal set A, each power set is denoted by this symbol. This is the power set of A. Let us have this example. If the universal set A represents the first 3 prime numbers, then its elements will be 2, 3, and 5. So if we are required to find for the power set, it is important to know how many subsets will there be for this set A. Okay, so we have to determine first the number of subsets for the set A. And the number of elements or the number of subsets of set A now becomes the cardinality of the power set. The cardinality of the power set of A is equal to 2 raised to the cardinality of A. And since there are 3 elements for set A, so we therefore have 2 cubed or 8 subsets. Okay, so we start with listing all the possible subsets of set A. We can have a subset B whose elements are 2, 3, and 5. As we say, a set is a subset of itself. So we can have another set whose element is B, another subset whose element is 3, another subset whose element is 5, another subset whose elements are 2 and 3, 2 and 5, another subset 3 and 5, and another subset is the empty set. So there are a total of 1, 2, 3, 4, 5, 6, 7, 8 subsets. And so now we are sure we have listed all the 8 subsets. We can now write the power set of A is a set containing the elements B, set B, set C, set D, set E, F, set G, set H, and set I. Or we can list the elements, all the elements, since B is a set containing the elements 2, 3, and 5. So notice, in the power set, each element in here are all sets. Okay? So all the elements in a power set are sets. And it must be the list of all the subsets of a universal set. Okay? Okay, let us discuss the operations on sets. The union of the sets. We use the symbol to denote union. The union of a set is the new set formed if you combine all the elements in 2 sets. Elements which are common in the 2 sets is written only once. So we have this set A has elements 2, 3, 5, 7. B has elements 1, 2, 3, 4, and 5. The union of sets A and B, A union B, is equal to the set containing all the elements which are found either in A or in B. So we start with set A. It has elements 2, 3, 5, and 7. So all these elements should be found in the union of A and B. 1 must also be found in the union. 2 is already written because it's common to set A. 3 is already written in the union. We have 4, so we write 4 in the union. So what you have here, 5 is already written as it is common in sets A and B. So A union B is a new set whose elements can be found either in A or in B. That's A union B. The intersection of two sets, intersection is denoted by this symbol. This is the set containing all the elements which are common in the two sets. Okay, so if we have here A intersection B, if our set A has elements 2, 3, 5, 7, and set B has elements 1, 2, 3, 4, 5, the intersection of these two sets is simply the set containing all the elements common in the two sets. So 2 is also found in the second set, 3 is also found in the second set, 5 in the first set is also found in the second set. So the intersection or A intersection B is the set containing the elements 2, 3, and 5. Let's have some more examples. We have here the set containing this element phi, union, and the empty set. So the union is the collection of all the elements found in these two sets. So we have the union, we have this symbol, and since there is no element in the second set, so their union is simply this set containing the element found in the first set. The set containing the elements 5, 10, and 15 intersection then the set containing the elements x, y, and z. So in this statement, we are required to find the set containing the elements common to the two sets. And since there is none, so their intersection is an empty set. Okay, so two sets which has no common element or whose intersection is a null set are called disjoint sets. So in the second example, these two sets are disjoint sets. The difference of two sets A and B is denoted by this symbol. This is A minus B. Is the set of all elements in A which do not belong to B. Okay, take note that it is not necessary that all elements in B are found in A. Let us have this example. A has elements 2, 4, 6, 8, and 10. B is a set whose elements are 1, 3, 5, 7, and 9. Set C has element 2, 3, 5, and 7. Number 1, let us find A minus B. So A minus B, we have set A has elements 2, 4, 6, 8, 10. B has element 1, 3, 5, 7, and 9. So what you're going to do is subtract from the first set those elements which are found in the second set. So 2, 4, 6, 8, and 10, none of this is found in the second set. And so therefore, the difference is the same set elements in set A. B minus C is, we have set B, whose elements 1, 3, 5, 7, and 9, minus set C, whose elements are 2, 3, 5, and 7. So we're going to subtract from the first set the elements which are found in the second set. So 1, 3, 5, and 7 are found in the second set. And so therefore, the difference will now be the set containing the elements 1 and 9. C minus B. This is C, 2, 3, 5, 7. B is 1, 3, 5, 7, 9. What are those elements in C which are found in B? So 3 is found in the second set. 5 is also found in the second set. 7 is also found in the second set. And so therefore, the difference C minus B is equal to 2. B minus A. We have here B has elements 1, 3, 5, 7, and 9. A has elements 2, 4, 6, 8, and 10. So as we look at these sets, 1, 3, 5, 7, none of this is found in the second set. And so therefore, B minus A will still be equal to B. A intersection B. A has elements 2, 4, 6, 8, 10. B has elements 1, 3, 5, 7, 9. And so since there is no common element in the two sets, their intersection is an empty set. B union C. So B has elements 1, 3, 5, 7, 9. C has elements 2, 3, 5, 7. Their union is the collection of all elements which are found either in A or in B. So we have 1, 3, 5, 7, 9, and we have 2 should also be included in the union. Okay? The complement of a set. The complement of set A is denoted by the symbol A prime. We read this one as complement of A. This is a set formed if a subset A is subtracted from the universal set. So in symbol, the complement of A is equal to the universal set minus set A. So let us say we're given the universal set, the set of the counting numbers 1 to 10. A, we have the elements 1, 3, 5, 7, 9. B has elements 2, 3, 5, 7. And C has elements 2, 4, 6. So notice that all of the three sets in here, A, B, and C, are subsets of U. Let us perform the following operations. A prime, or the complement of A. The complement of A means the universal set minus A. So the universal set has elements 1 to 10 minus the set A whose elements are 1, 3, 5, 7, and 9. So we are going to subtract all these elements 1, 3, 5, 7, and 9 from the universal set. So the complement of A will now be 2, 4, 6, 8, and 10. The complement of B is the universal set minus set B. So this is the universal set, and set B has elements 2, 3, 5, 7. Again, the complement of B is we are going to deduct all these elements from the universal set. So the universal set less this 2, 3, 5, and 7. So what is left is the set containing the elements 1, 4, 6, 8, 9, and 10. The complement of C is the universal set minus set C. So we have the universal set less the elements found in the set C, 2, 4, and 6. So universal set less these elements will give us the complement of C. That is the set containing the elements 1, 3, 5, 7, 8, 9, and 10. So take note the difference between the complement of a set and simply the difference of two sets. When we talk about complement of a set, your set must always be a subset of a universal set. In the difference of two sets, for example, B minus A in here, again, the elements of A need not necessarily be all found in B. So we have here set B has elements 2, 3, 5, and 7, while set A has elements 1, 3, 5, 7, and 9. In B minus A, all you need to do is just subtract from the first set those elements which are found in the second set. And that includes 3. 3, 5, and 7 are found in the second set. So our B minus A is the set whose elements are the remaining elements in set B. And that gives us set whose element is 2. B minus C, so this set B and C is 2, 4, 6. Subtract from set B those elements which are found in set C. And that includes only element 2. So the difference will be the set containing the elements 3, 5, and 7. A set product is also known as Cartesian product or cross product. So the set product of two sets A and B is represented by this symbol, which we read as A cross B. A cross B is the set of all possible ordered pairs AB, where A is an element of the first set and B is the element of the second set. Let us have this example. A has elements 1, 2, and B has elements A, B, C. We are required to find A cross B and B cross A. A cross B, we consider first the first set A, whose elements are 1, 2, then B, whose elements are A, B, C. The cross product is obtained by pairing each element in the first set to an element in the second set. So we have the first element is an ordered pair 1A, 1B, then we have an ordered pair 1C. Considering the second element in set A, we have 2A is another element in the set product, 2B, and 2C. So there are a total of 6 elements in the set product A cross B. B cross A, so take note, we start with the elements in set A paired to an element in, or the element in set B paired to the element in set A. So we have the first ordered pair is A1, the second ordered pair is A2, then we have B1, then B2, and then we have C1, and then we have C2. So this is now the cross product B cross A. Now, set product is very important in higher mathematics. I hope by this time you already have a clear idea on what are subsets and supersets, universal sets and power sets, and the different operations on sets. In the next video, I am going to discuss Venn diagram. Thank you for watching.